So the assignment you did with these two exam questions, looking for you to work a bit on your integration skills. So this first question is just routine in the sense that it's integration, you've got some limits on it, you've got a square root symbol there, so hoping that in the first instance you knew to rewrite that expression so that it was in the form of x to the power of half. Now at this point we are actually ready to integrate. So you need to have done that first. Rules for integration are that you should increase the power by 1 and divide by the new power. So here increasing the power by 1 would make that become 1.5, which would be 3 over 2, and we would then be dividing by 3 over 2. There's no plus c when you've got your limits. Before I would do anything with the limits, I would expect this to be tidied up, and remember that dividing by 3 over 2 is the same thing as multiplying by 2 over 3, the fraction flipped. So I'm going to rewrite this expression here with a 2 on the top, 3 on the bottom. In terms of my x in power, I should understand that that's the square root of x cubed. I can either do the cube and then take the square root, or we can take the square root and then cube it. So when we're doing this, limits on there, 9 and 4, then looking for you to substitute into this expression with your upper limit first, so knowing that that would get you 2/3 square root of 9. I'm going to put brackets around that because I'm going to do the root first and then I'm going to be cubing, and then we're going to do minus, and we will have 2/3 of the square root of 4, and again I'm going to put brackets around that, and then I'm going to be cubing that answer. So 2/3 times square root of 9 is 3, 3 cubed is 27, minus 2/3 times square root of 4 is 2 times 2 cubed is 8. Now clearly that first fraction multiplication is going to simplify if I could cancel. However, notice that the second fraction doesn't, so I'm still going to be left with thirds. So I'm actually just going to leave this as thirds initially. So 2 times 27 would be 54 thirds minus 16 thirds, and if you subtract those two things you get 38 over 3. Changing that back into a mixed number would get you to 3 into 38 equals 12 times, remainder 2, so 12 and 2/3. So remember, like this, you could get this in a non-calculator paper when you do that sort of thing. So it's important that you take your time, a line at a time, don't try and rush it. It's not about trying to have fewer lines of work in, it is about making sure you understand what you're doing. So second question, still on integration, slightly different in that it's an actual equation that you've got going on here. So what you're being told is that you've got this integral with limits on it 1 to a, and you've got the integral of that expression there gives you the answer of 18, and you're asked to work out what must a be. So normal procedure would be to integrate that expression, so increase the power, divide by the new power. If there's just a number there, remember that's just about bringing back the x. Put our limits on the square brackets, we'll have that equals 18 on the other side. Before I do my subbing in, I'm going to simplify, so that just becomes x squared plus 5x, and your limits of a and 1 equal to 18. Now I'm ready to sub in, so upper limit a squared plus, I'm going to have 5a. Then we're subtracting the lower limit. Now because there's two terms in here, I'm going to have a bracket when I sub in, so minus doing 1 squared plus 5 times 1, and we know that that is all equal to 18. So this is going to give me a squared plus 5a. Inside that bracket I'm going to have 1 plus 5 times 1, so 1 plus 5, 6. So I'm subtracting 6, and that is equal to 18. Now what you've got there is a quadratic equation. To solve a quadratic equation, you need to make that right hand side equal to 0. So I'm going to subtract 18, which means I end up with minus 24. And I'm then trying to solve this quadratic equation, and that's just straightforward factorising, looking for two numbers that multiply together to give me minus 24, and when I add them I get positive 5, so that would be plus 8 and minus 3. That then produces my two little mini equations, so I get a plus 8 equals 0, so a equals minus 8, and I get a minus 3 equals 0, so a equals 3. And you might think you're finished there. However, if you read the question, you'll see that you are finding the value of a where you're specifically told that a has to be greater than 1. So that would mean down here that the a equals negative 8 isn't valid. So what we say is, since a is greater than 1, your solution is a equals 3, and that would be it.